Yeah, I want to work a problem from Chapter 5, Number 1, Section 1. It's number 13 out of the book, or the fifth problem in that MyMathLab homework assignment. And in it, he says, for the function, find the critical number, the open interval over where the function's increasing, and the open interval over where it's decreasing. And I'm assuming you've already either read through the section or watched the video or both, so you know what we mean by a critical point. Critical point is where your first derivative is 0. So first, to find the critical point, we need to take that derivative. So f prime of x is derivative 2.30, 1.6x is 1.6 minus 0.3, which is a multiplicative constant. Derivative of x squared is 2x. So that's going to give us 1.6 minus 0.6x. And to find the critical points, we set that to 0. If we solve that for x, we'll get 1.6. We'll move to the other side. We get 0.6x. We divide. We're going to get 1.6 over 0.6 is x. You can reduce that. Multiply by 10 over 10. That's 16 over 6, which is 8/3. So we get a critical point at 8/3. In other words, if I plug in 8/3 into that equation, I'll get a 0. Now, what that's telling me is that that's where my derivative is 0. And so that sort of divides the axis. The only place it can change sign is where it goes through 0. So remember that a positive first derivative tells you that you are increasing, because it has a positive slope, and a negative tells you you're decreasing. So ours is, if you will, we have sort of our number line here, and at 8/3, we know our f prime is 0. And so we need to figure out what it is on either side. So let's do some test points. All right, so what do I want to do? Well, let's pick one to the left of, and I like 0. 0 would be over here, and, well, let's put it up there. And get my pen back. We'll go there. So 0's there. That's our x. We'll write x is above. We'll write our f prime values here. F prime is 0. There at 8/3, and f prime of 0 will be 1.6 minus 0.6 times 0, which is just going to be 1.6, which is positive. So it's positive over here. Whoops. All right, so, and I know that because it's 0 at 8/3. So that means that's the only place it's 0, which means if it's positive anywhere over here, it's positive all the way to 0. Now, on the other side, let's choose a test point of, well, what's bigger than 8/3? That's 2 2/3. So let's pick a test point of 3. So let's evaluate our first derivative at 3. And I don't know why it screens out. I gotta figure out why it does that. So I have 1.6 minus 0.6 times 3, which will be 1.6 minus 1.8, which is minus 0.2. So over here it's minus. Goes through 0. So this thing is increasing, has 0 slope, which is either, its maximum value or its minimum value, and then at 8/3, and then the derivative gets positive after that. So if I want to know the interval that over which it is increasing, that's going to be the same as the interval over which the first derivative is positive. And we saw that if you start from the left, minus infinity, and walk to the right, then it's positive up until you get to 8/3. We'll make that an open, because at 8/3 the derivative is 0. In other words, it has a positive slope. Whereas the interval over which it is decreasing is going to be from 8/3 on, so plus infinity. And that's where, if you plug in the numbers on that interval, you will get a negative number for your first derivative, which means you have a negative slope. So that's the answers to the questions on that problem. First one being, what's the critical point? And the next one being open intervals when the function is increasing, and C, open intervals at which the function is decreasing. So I hope that helps. I'll see you in the next problem.